Welcome to May 2nd's LeetCode challenge. Sort array by parity. Given an integer array nums, move all the even integers at the beginning of the array, followed by all the odd integers. Return any array that satisfies this condition. So we have the array nums here. This given. We want to sort such that all the even number comes before the odd number. So there's many arrangements for this, such as you have a 4 and a 2 that goes before 3 and 1. You have 2 and 4 goes before 1 and 3. And then you have 4 and 2 goes before 1 and 3. And also you have 2 and 4 comes before 3 and 1. So it's kind of 4 different type of outputs here, but they're all acceptable. If we have nums array of 0, then you return 0. So the constraints of the length of num is between 1 to 5,000, and each index of nums is between 0 to 5,000 as well, the length I mean. So yeah, let's go about solving this. So the most intuitive or easiest way of approaching this is use a custom comparator when sorting. So sort by the parity, such as you have something's nums.sort, and you could use a key of the lambda x such that x is divisible by 2, and then once it's sorted you could just return nums. Alright, this should work. So, wait a minute. Lambda, sorry. Alright, and that's submitted. It should work because it's using a sort algorithm and you're using basically a custom comparator. Time complexity and memory usage is not really the best because we're using, obviously the question is easy, so that we could just use a built-in sort function. And the sort function itself, time complexity is big O of n log n, because the length of a, and space complexity is big O of n, depending on the sort, the built-in implementation of sort. And that's for Python. Just to kind of kick this up a notch, I mean, you could use sort of any sort, but to improve this, we could use a Quicksort algorithm. So we could actually solve it in place. So if we want to do this sort in place, we could use Quicksort. And Quicksort is like a standard algorithm. So basically it goes that we have two pointers, I and j, for instance, and if we loop the invariant, everything is below I has a parity of 0. For instance, you have the index at k at the index num is divisible by 2 is equal to 0, and that when k is less than I, then everything above j is a parity of 1, right? So we can just sort it that way. So for instance, if you're so there's 4 cases we need to consider, right? We need to consider so given, no, I'll just type it out. So say we have nums at index I, and you take the modulus of that, divide by 2, and you take a at index j for 2 pointers here, modulus of 2. So there's 4 conditions where this is of this tuple, right? You can have it such that you have 0, 1, so the parity would be 0, 1, right? Where the index modulus of index I is 0, and the modulus of index j, nums of j is equal to 1. That means that 0, I is divisible by 2, therefore it's even, and therefore j is odd parity. And then we have 0, basically, we have where they're both even, and then we have where they're both odd. Alright? And that's kind of the idea behind using this quicksort algorithm. So what we want to do is go through all the 4 cases, loop the invariant or it's maintained, and then you just basically sort it by the smallest, sort it by ascending order as well, just to make it look a little nicer, so we eventually get done with the array sorted as desired as here. Alright, let's go about doing that. So first off, we set up our 2 pointers I and j, and we also need a, no, that's I and j for now, set I to 0, and j to be the length of nums minus 1. Alright, okay, we got our 2 pointers, while I minus j, so I less than j I should say. We loop through if nums at index I has a parity modulus 2 I should say. It's great if the parity of numbers at index I is greater than the numbers of parities at index j. Divisible modulus 2. I mean, the answers you're going to get here is if it's even or odd. So saying if numbers at index I is odd while numbers at index j is even, then what we want to do is swap I and j. So it would be nums at index I, nums at index j, reassignment, such that in nums at index I is equal to nums at index j, and nums at index j becomes nums at index I. Okay, we swap it, and then we know to check for those statements such that nums at index I. We know that I have to take the modulus of that by 2. We say if the numbers at index I is even, so therefore it's equal to 0, the parity is equal to 0, then what we want to do is increment I by 1, right? So we move the pointer to by 1. If nums at index j is even, is odd I should say, then we decrement j by 1. And then return nums. Basically, if it's even, we don't touch it, and therefore we move the pointer to the right. And then this is for odd. So any pointer on the left side, on the right side, if it's an odd number, then we leave it. Then therefore we move the pointer to the right. So everything, if it's anything on the left side is even, we swap it with the right side. If the right side is odd, I mean the left side is even, and the right side is odd. I mean we swap it. And then this should work as well. This is using Quicksort in place. And there you go, accepted. Wow, this actually, time complexity is actually a little bit less. It's actually big O, yeah, it's big O n. Well, n is the length of a, so each step of the while loop takes j minus I times to decrease at least by 1. So note that the quicksort algorithm is normally big O of n log n, but this is a big O of n because we need one pass to sort the elements as well. Yeah, and then the space complexity is in place, so it would be constant space. And that's it. That's all. 2 ways to solve it. Have a great day, guys.